Yeah, you can proceed. Presenting today, Michael Alex with the DevOps Cloud Engineer. We'll be talking on server operating system versus desktop operating system. Um, Michael, you have the floor. Thank you very much.
Okay, thank you very much. So, as you've said, my name is Alex Michael, a DevOps engineer. And my topic for today is server operating system versus desktop operating system. So let me give a brief introduction before I dive into my slides. So recently I started my KD presentations with what is the job of a DevOps engineer, what they do and all that. And then I dive into servers demystified. So servers demystified, I was trying to say, okay, what is a server? What do they do? How do we benefit from them? How do organizations actually utilize them to make the best use of them? And today I'm going to be diving more into operating systems. Now we have server operating systems. We also have desktop operating systems. Not all operating systems actually are the way we actually see it to be. For instance, whenever we check our computers, we say, okay, fine, I have a Windows operating system. And with my Windows operating system, I'm able to download I'm able to download Microsoft Word. I'm able to download GitLab or Git or any software of your choice, maybe Photoshop and all that. Now, that Windows operating system you're having on your personal PC is not the same operating system that you use on your server. And that is what I'm trying to explain here. So let me go straight into my slide. So introduction. So standalone operating system becomes a complete operating system that works correctly on a computer or laptop for that specified part. Yes, a standalone operating system is that operating system that you have on your personal PC. In fact, operating systems are not just tailored to PCs alone. Rather, they even go as far as even our devices, such as our tablets, our phones, anything that, of course, we use to communicate or to send messages and all that, they are actually having an operating system. Now, if you look at it, whenever you have your phone, sometimes you find out that you start seeing some funny programs on it. Maybe they want to flash it. You give it to an engineer and say, okay, fine, my phone is not working the way it's supposed to work. So you take it to an engineer. Okay, please tell me to flash it. What you are trying to tell the engineer to do is that he should change the operating system on the phone. And that is why there's something called an Android operating system also, which you put in an Android phone so that it can be able to communicate with you. And also you are able to communicate with it in such a way that you are able to put in applications. And then with that application, you are able to communicate with the phone for it to do some specific functions. So from this introduction we have here, standalone operating system becomes complete operating system when it works correctly with a computer, which is very true at a specified part. But for a server operating system, it says becomes a feature of operating programs that works on several computers that maintain their origination on the server and hence control various users. Now, what this is trying to say is that for a server operating system, not like the personal computer that you have, not like your phone that you have or your tablet that you have, this one is different. Actually, we are managing different users. And when you are talking about users, this time we are talking about devices, not people per se, because it is actually people that give these devices specific functions and tasks for it to do. So whenever I mention users, or whenever most of the time a programmer or a DevOps engineer or a network engineer is talking about users, he's actually talking about devices. He's talking about different computers. So that is what a server operating system does basically. It helps us to control. It helps us to give a tab or a log or how we are able to communicate with different devices, maybe in an organization or maybe in a particular space. It could be from, let me just say, from one building to another building in another location. So let me go on. So standalone operating system. A standalone operating system is a complete operating system that works on the desktop computer, which is what I said earlier. So what I'm trying to say the other time when I mentioned your personal PC, that is a standalone operating system. We have different ones. We have Ubuntu, we have Kali Linux, we have Windows, but of course, many of us know Windows as an operating system. And of course, without Windows, it's not possible for us to have those applications which we actually use in communicating with our computer. So many of us actually download these applications, but we don't know something. These applications are not there for you to just use. Rather, the main function of your application is that this application helps you to take your requests and then process them into languages in which the computer is able to understand. And then, of course, it works on those commands and it gives you feedback. And that is why most of the time, there must be an application that must be mounted on this operating system for it to work effectively. So the standalone operating system is a complete operating system that works on a desktop computer, notebook, computer, or mobile computing device, and so on. Some standalone operating systems are called client operating system because they also work in conjunction with server operating system, and that is very true. There are some standalone operating system. Some of these are our normal PC. They actually work in conjunction with a server. There must be maybe there might be a server somewhere that's actually feeding it information. And of course, I want to also bring out something this way, that you can also make your PC to also work as a server, but I don't want to go into that now. Maybe I'll talk about that later. So let me continue. So client operating system can operate with or without a network. It is very true. Your computer can operate with or without a network. It does not need a Wi-Fi. It does not need to connect with other computers before it works. Whatever you want it to do, it will do for you, as long as you have your PC working fine. So other standalone operating systems include networking capabilities, allowing the home and small business user to set up a small network. And it is very true. It is also possible for you to have your computer, your phone, your tablet, maybe your speaker, and your mouse all working as a network, meaning that they all communicate with each other. Maybe your mouse is communicating with your computer via Bluetooth, then your speaker is communicating with your PC also with a Bluetooth. Then maybe your phone is connected to your PC also, maybe using a cord, and maybe your Wi-Fi is also communicating with your PC using a cord and all that. So they can all work together as a network. It is very possible, and yet they all have their own operating systems. So that is what we are just trying to bring out from that. So examples of currently used standalone operating system are Windows 7. We all know Windows 7, we know Windows 10, we know Windows 11. As far as the upgrade, we all know these things, this operating system. Then we have our Mac OS. Our Mac OS, that is the likes of the Apple, and then Unix. Unix is known to programmers, is known to network engineers, and also Linux. So these are actually operating systems that also give rise to some other operating systems, such as Ubuntu, Red Hat, CentOS, and so on. So now we are going to be diving deep into the server operating system. So I'm actually giving an introduction of how the server operating system was, but let's go deeper in this. So server operating system becomes a feature of operating programs that works on several computers that maintain their origination on the server and hence control various users at the same time. So as I said earlier, the work of server operating system is actually to give information to other operating systems, because it is a server. The primary function of the server is for it to store information, is for it to actually gather information. And of course, whenever other devices needs this information or data, then they request for it. So there is an operating system in the server that actually helps the server to actually carry out this. So you cannot put a server operating system in a standalone operating system or in your normal computer or your normal phone. It's not possible. Why? Because it is actually made for something different. It is designated for a particular function, and that is to maintain several computers. It is to maintain several devices, and it controls these users at the same time. So a server operating system, likewise called a server OS, is a practical framework particularly intended to keep running on servers. So as you can see, it is intended to run only on servers, not on personal PCs, which are specific PCs that work inside inside a customer stroke server design to serve solicitation of solution of client PC on the system. So my next slide. I'm trying to be fast so I can keep to time. So a server operating system is an operating system that is designed specifically to support a network. So let me just explain this. So a server operating system, as it says, is just there to support a network, because of course, whenever a device communicates with another device and that device communicates with some other device again, of course, there must be a central point which all these devices must be able to store their information. There must be a central point which these devices also must be able to retrieve information, because of course this information which is communicated, or should I say which is being transferred from one device to the other, must be stored somewhere. If it is not stored anywhere, then you find out that there is no need for the network in the first place. And that is why for network engineers, in the beginning, what they do is that they use switches, they use bridges. That is why all those technologies are outdated now. Why? Because there is no way you are able to store your data. Yes, I know computer A is able to communicate with computer B, and whatever computer C sees, computer D can also see it. But where is a central point where they can actually share this information, where they can store this information, where they can make good use of this information whenever it's needed? Just like some days ago, I mentioned something that, just imagine that you make a transaction in a bank or in an organization, and you find out that 50 years later, you are coming back and you are still seeing that same transaction that you carry out 50 years ago. So that is credibility. But just look at it, assuming there is no server. That means whatever transaction you've made for that day is just for that minute, not even for that day, it's just for that minute. Immediately you are leaving the place, it means that your information is lost, the data is gone. Whatever transaction you've done is actually not what, it's not going to scale through even the next day or the next minute. So that is what the server operating system is intended to do. It's intended to actually support a network. It helps the network bring out the best of it. So a server operating system typically resides on a server. Yes, it must be on a server. The client computer on a network rely on servers for resources. Now that is what I'm talking about when it says the client computers on a network rely on server resources, because it is in the server that is where it actually gets all the information it needs to run. And we should know something. That is why data analysis, data sciences and all that, anything that has to do with data intelligence, artificial intelligence, machine learning, all those, is actually the in thing today. Why? Because data will always be generated. For every organization, even to a school, even to an hospital, whatever sector it is it in administration, data is being generated. And if you notice, most of these applications that we actually build are built using data. Without data, it's not possible for an application to actually run one. It's not possible for an application to solve a problem when it has no data about the problem it's trying to solve. So that is why, as you can see, today, data is everything. Data is life, as Saito has told us. So the client computer on the network rely on the server's resources. I mentioned that many standalone operating systems discussed in the previous section functions as clients and work in conjunction with a server operating system. So examples are Mac OS server. Yes, we have a server called Mac OS. We also have Windows server. We have Windows Small Business Server 2008. We have Linux FreeBSD and Solaris. So the key differences between standalone OS and server OS. Standalone operating system becomes a complete operating program that works correctly on a computer or laptop for that specific part. On the other hand, server operating system becomes a feature of operating programs that works on several computers that maintain their origination on the server, hence control various users. So what this is just trying to say simply is that standalone just works with just a user alone, while server operating system, of course, it can work on different users at the same time. So the second one says, some of the leading examples of a standalone operating system include DOS, Windows 3X, Windows 95, Windows NT Workstation, Windows 98, Windows 2000 Professional, Windows XP Home Edition, Windows XP Professional, and so on and so on. Then, on the other hand, some original examples of server operating systems are Mac OS Server, which we've already mentioned, Windows Small Business Server 2008, which we've also mentioned, Linux Free BSD, we've mentioned that, and Solaris. So what this is just trying to tell us is just examples of these two different servers. Then, a standalone operating system provides its services and deals with just one computer at a time, even if it has a connection and with other computers and servers. So, of course, just like we just said now, standalone is just one computer at a time. Even if it should communicate with another computer, it's just one computer at a time. Unlike, of course, the server-based operating system, which deals with computers on the network. Even if it is installed, it can communicate with different computers at the same time. It can share information with different computers at the same time. It can disseminate information and, of course, modify information. Will I say modify? No, I won't say modify, because that is not the work of a server. The work of the server is not to modify. If there should be any modification, then it should be the standalone operating system that the user is going to use in doing whatever modification he has to do on that data, then of course pushes it back to the server, because the server just works more as a database or more as a place where it stores information. So another difference is that the server operating system becomes a practical framework, particularly intended to keep running on servers, which are specifically PC that work inside a customer server design to serve the solicitation of client PCs on the system. Standalone operating system becomes an entire working framework that deals with a desktop or journal PC, a system operating structure called Arrange OS or NOS, and acted as a practical framework backing a system. So this is just talking about the frameworks that these two operating systems are being they do work on. So now we are going to be talking about different types of server, because now we've talked about the standalone operating system, we've talked about the server operating system. So we want to now dive, okay, fine. We've talked about server operating system. What kind of servers do we even have? What type of servers do organizations actually use? What kind of servers should I even employ if I'm to start maybe start a business and all that? So now we'll be starting with a web server. Now, a web server shows pages and runs applications through web browsers. The server your browser is connected to now is a web server that delivers this page and the images on it. The client program in this case is a browser like Internet Explorer, Chrome, Firefox, Opera, Safari. So I might not be able to read all this, but let me just explain it because of time. So a web server, what it actually does is that it keeps web pages, so that whenever you need these web pages, then it is able to retrieve it for you. Just for instance, you go on Google, you say, okay, Google, I want to search for Fox. Now, Google is going to go somewhere to actually retrieve the pages for Fox. So that is the work of a web server. So all the information about Foxes have already been stored somewhere in the web server, and then of course it retrieves it for you. So that is what you can see actually in the picture by the right, when you see, of course, a big machine and different computers. So these different computers will actually send requests to this big machine, and of course it's going to disseminate it to each of them. And that is why I mentioned the other time that the server operating system has the ability for it to work with different computers at the same time, unlike the standalone, which is able to only work with one computer at a time. So that is for web servers. So the other server we have is the FTP server. So what this basically does is just for files. You know, we talked about web servers for web for web pages, but for FTP servers is for files. I can remember when I was in university and we were wanting to send music, we want to send PDF, we want to send all that. We had to start downloading FTP. I can't remember, but I can remember vividly that the name started with an FTP. So it was here that I was like, okay, fine. So this is what it even means. FTP servers is for sharing files. Actually, that is what it basically does. And it does this wirelessly. You don't need a wire to actually do this. So that is what it basically means. But let me just read it. So FTP servers moves files through file transfer protocol, FTP. FTP servers are accessible remotely using FTP client programs which connect to the file share on the server, either through the server's built-in FTP capabilities or with a dedicated FTP server program. So that's what FTP is all about. Then we have other types such as identity servers. The identity servers is where, okay, fine, a server where you keep users authentication, you keep users login details, you keep their passwords and all that. So of course, whenever they need it, you find out that it is being retrieved. And that is what even happens whenever we are maybe in a Chrome browser. You find out that whenever I just type the first maybe A, it brings you the old password and all the login details. It is because there's actually a server which is actually dedicated to saving the identity, to saving anything that has to do with login details, maybe faces and all that. So that is what identity server is all about. Then we have the Active Directory, which is a centralized place for managing users. That is what it basically does. I might not have the time to actually read it. So as you can see, we have the file over here and we have so many people in this place. If you can see the picture by the right. So this file actually is the server and it's managing different people at the same time. And that is why most of the time you say you are giving somebody admin access. Admin access, why? Because the person is able to manage this type of users, remove users, add users, and do whatever modifications he wants to do. So thank you very much for listening to this presentation. And if you have any questions, you can ask. Thank you.
Yeah, thank you very much, Alex. But because we will not be taking questions. Yeah, thank you very much, Alex.